Hi. Today we have a bit of a shorter lesson today. Anyways, today is just going to be all about angles. Now, this is a problem you'll probably come up with a lot. You have some random shape, maybe this, maybe instead you'll have a bunch of lines. I don't know. But then the point is, the question is asking you to find the specific angle x. And today we'll just be going over a few strategies in doing so. So first of all, let's go over some of the rules. The sum of all interior angles in an n-gon, which is a polygon with n sides, is equal to 180. 180 times n minus 2. And if it's a regular n-gon, then you divide this by n for each angle. So for example, an octagon, this has 8 sides, so 180 times 8 minus 2 divided by 8 is equal to that's 135 degrees. So if this is a regular octagon, which means all angles are the same, that means this angle here will be 135 degrees. Or if you have a triangle, yeah, there's a simple example. So actually, how about a pentagon, and you know these three angles, and four angles, I mean, and they want you to find this one, then you know the sum of them would be 180 times 5 minus 2, sorry. So that would be 360 plus 180, that's 540 degrees total. So that's one method you can use. Next, if you have a circle, now, and you have a sector here, the length of this arc, let's call this AB, is equal to radius times the angle theta, where theta is in radians. Next, for angles intercepting arcs, we went over all the rules in lesson 10, so you can find that in the description below. Next, angles which form a line add up to 180 degrees. Yeah, that's kind of obvious, but still. So if you know this angle, let's say this angle is, I don't know, 100 degrees. Since this is on a straight line, that means you know this must be 80 degrees. Simple, but you'll be surprised how some people overlook it. And if you're looking for an entire circle, that altogether is 360 degrees. So I guess since these are opposite angles, it wouldn't really apply, but if you had something like this, and this is 75, this is 65 degrees, this is, let's say it's also 75 degrees, that means this angle must be 115 degrees. Simple, but yeah. Next, if you have a right triangle, you can use sine and cosine. So first of all, there's a 90. So if you have something like with sides A, B, C, then you know the sine of this angle is opposite over hypotenuse. So let's call this angle theta. So sine theta is equal to A over C, and if you know both A and C, then you can get theta is equal to sine -1 of A over C. Assuming you have a calculator, of course, or with the special angles that can also be used. Next, angle bisectors create two equal angles. Now, normally they have to tell you if it's an angle bisector, but they do. If this is, say, it's 80 degrees in total, that means each side is 40 degrees. Sorry, not 45, 40 degrees. That's only if they specifically tell you that's an angle bisector, though. Next, isosceles triangles. If these two sides are equal, that means these two angles are also equal, which means if you know, this angle, if we say it's 30 degrees, and the sum of all angles is 180 degrees, that means 180 minus 30, that's equal to 150, which means that each of these angles have to be 75 degrees. Next, equilateral triangles have all vertices 60 degrees. Honestly, this has been covered in like other rules like the regular polygon, because equilateral triangles are regular polygons, but for some reason they tend to show up a lot more in questions because triangles are a bit more annoying to work with and have a lot of interesting properties. Next, vertical angles. Now, vertical angle just means when you have cross, that means this angle is equal to this angle is equal to this angle. So if there's any shape with a cross like that, you'll know that they're equal. Let's see. Next, similar and congruent triangles. If you have a triangle like this and a triangle like this, and you know they're similar from whatever law you have, that means you know this angle is equal to this angle is equal to this angle, and this angle is equal to this angle. And you can figure out similarity from if the three sides have the same ratio, if two sides have the same ratio and they share an angle in between them. And honestly, there's a lot of rules for proving similarity, which have also been gone over. Let's see, parallel lines. That's another interesting one. In the parallel lines thing we mentioned, if there's a transversal, which means like if these two lines are parallel, there's a line that's going across it. This angle is equal to this angle is equal to this angle, which is, these angles are also the same, these angles are also the same. And since these are on a straight line, angle A plus B is equal to 180 degrees. So basically, if you have any one of these angles, you can figure out all the rest of them. And keep in mind that they don't always have to give you a parallel line. You can always just draw them into the diagram yourself if that helps. Let's see. Next, exterior angles of a polygon sum up to 360 degrees. So let's see. So if you extend all these lines here and you get the sum of all these angles here, they always add up to 360 degrees no matter what. And let's see, finally, perpendicular lines. Perpendicular means there's 90 degrees to each other. If you know it's perpendicular, then good for you. You know it's 90 degrees, and you know that this is also probably going to be 90 degrees, assuming it's a straight line. Another time you'll know it's a perpendicular angle, even if it's not stated explicitly. If this is a tangent line, and that means it is always perpendicular to the radius of the circle. So if you have a tangent line and a circle, you pretty much always have one right angle. Anyway, just a quick overview of all the different ways you can figure out what an angle is and a competition problem. And, just to annoy you, I'll give you a few questions to work with. Let's see. I'll give you a circle here. And we'll give it a center O. Let's see. We'll also give you a diameter. This is CD, I guess. And let's give you another point here, E, because of course you have to make it more complicated. And let's also give you a point here, F. Now let's draw a line through DF. And how about a line through DE? And we'll complete this as a triangle. And you know what, let's extend this a bit too. And I'll label this A and I'll label this B. This is an interesting diagram, isn't it? And I'll just tell you this, AE, even though it's kind of drawn badly, it's supposed to be a straight line, and same with FC. These are supposed to be one extended line. And just so you know, the way I've told you how to draw it is not necessarily how you would really draw it. As in, I didn't just extend DB like randomly. It's supposed to be extended to match this line. So let's see. So like I said, O is the center of the circle, and we'll give you. Wait, what angle is this? Okay, it's angle FAC is equal to 40 degrees. And we'll say that a segment CF is equal to 40 degrees as well. And in case you don't know, that just basically means that this angle here is 40 degrees. And finally, the question is, what is angle CAB? And since it would be a bit boring just to give you one question, let's give you another one. Okay. I'll give you a triangle here. Triangle PRQ, or PQR if you want to go the other way. And let's say, and I'll give you an angle bisector here. I'll call this point S. And I will say this explicitly, RS is an angle bisector. And let's see, we'll extend PQ to this point, let's call it D. And we'll draw another line here, call it C. Now, in this case, CD is perpendicular to RS. So even though it doesn't look like that, this is a right angle. And we'll have two more angles here. Angle M and angle Q. And actually we also have angle P here. Now, prove that M is equal to P plus Q over 2. Anyways, have fun with those two questions, and if you have any questions, feel free to ask in chat. Thanks.